Hello, everyone. My name is Tim Chou. This is one of five different presentations about key technologies that I think are going to be important from this year and beyond. Here, we're going to talk about edge computing. I'm going to take a little bit different tack than I did in some of the other presentations and kind of share with you what I think some of the important aspects of edge computing are going to be, and some of the things that maybe you should think about if you're starting to work in the world of edge and edge computing. In the 5G section, we talk about one of the huge advantages of 5G is that it allows for much denser connections, meaning way more connections per square kilometer. This is actually the city of Mumbai, and I asked in that question or in that session, I said, what do you think the most densely populated city in the world is? And turns out it's Mumbai. So I was curious, well, so how many people are in the densest part of the world? Turns out there's about 30,000 people in a square kilometer in Mumbai. Maybe there are a lot of people. There are probably certain sections of Sao Paulo or Rio where it's highly dense, but 30,000, when you think about it, I mean, 30,000, everybody has a cell phone. Great. What are the other 970,000 connections for? We did do a long conversation around the Internet of Things, but I think where we're headed to is increasingly those connections are all not going to be about connecting to people, but connecting to things. And whether that's an automobile or a gene sequencer or an ultrasound or a compressor, it's to be about connecting to those things. Now, realize today, while some of these machines are getting smarter and smarter, if I really want to try to figure out how to connect to let's just make a point of it, there are probably 600 billion things in the world today. If I want to connect to those, then how am I going to do that? Well, I believe the only answer to that question is you're going to have a computer, what I'm going to refer to here as an edge server, that enables you to talk to the machine itself, whether that's a blood analyzer, a tractor, a construction machine, etc. So to talk to the machine and also to talk out. Okay. So what we're going to talk a little bit about in this section is what is the nature of those edge servers? What are the requirements of those edge servers? What attributes are we going to need to see in order to do this and to start to take advantage, as we talk about in the section on the Internet of Things, the advantage of that to both the people who make machines as well as the people who use machines. Just so you can think about it, the notion of an edge server is not a new idea by any stretch. If you use Netflix, you're already using edge servers, meaning there are a set of servers that are much closer to you, your laptop, your phone, etc., which serve up the movie. This is because obviously, if they can store all the movies in one location on the planet, but the communication cost to get from and the time it would take to get from your laptop to that centralized location, you couldn't watch it in anywhere near real time. So Netflix and others have deployed edge servers. There are about 10,000 of these around the world, which are connected, which enable you to get to the data in a much higher speed way than you would in a totally central approach. Just to give you a sense of what one of these looks like, this is actually a picture of a Netflix edge server. So I'm going to talk about 5 different things I think are going to be important to anybody in edge computing. The first is the edge server should be powerful. There's no reason at this stage, given the plummeting cost of compute and storage, that you shouldn't have powerful edge servers. I mean, gigahertz CPUs, GPUs, relatively large memory and storage are very inexpensive at this point in time. The other thing your edge server needs to have will be a flexible and scalable networking technologies. We talk about connecting. So connecting to the machine itself, connecting out of the machine, and whether that's going to be through Wi-Fi technologies that we talked about in the section on 5G, or through cellular technologies, whether that's 4G or 5G, you're going to need to have scalable and flexible networking technologies to connect the edge servers. The third big aspect is you're going to want to have these edge servers managed. So I don't think there's any surprise right now that security is a big issue with a lot of people if you haven't been reading the news. And by the way, just to make a point of it, a lot of the break-ins that have occurred, the high-profile break-ins, Target Stores is an interesting case study of this, have actually been break-ins not through coming in through somebody's laptop or anything. It actually was coming through a HVAC system. So a lot of things out there which are on networks are very poorly protected. And so if you're going to develop edge computing technologies, security, and obviously in the case of healthcare, privacy are going to be top of mind of how I'm going to manage security, manage the availability of these edge servers, manage the performance, and obviously, as with all things, managing change in these edge servers, whether that's in the underlying infrastructure, the hardware, all the way up to the software stack. The fourth major thing I think you have to think about is how are you going to standardize the data? Because at the end of the day, that's what's very interesting about doing this. And I'm going to help you think about data as 4 different types of data. So static machine data, what's the serial number of the gene sequencer or the combine harvester? Where is it located? What's the temperature in the room? What's the elevation, et cetera? Dynamic data, so that could be everything from time series data coming off a laser in a gene sequencer to up to date oil temperatures in my compressor, et cetera. It could also include error codes, log files that are generated. So dynamic machine data. And then the last class, I made up this word, nomic data. So nomic data means the data that the machine generates. So it comes from the word genomic, meaning that's the genome sequence. Agronomic data is, what's the boron level at this point in the field, et cetera. So nomic data is the actual data that's being generated by the machine. So you're going to have to think about how you get data to get standardized across these different categories of data as you connect to these machines. And finally, your edge computing environment needs to be able to support applications. There's many different things that could be done with data from machines. These could be production applications that independent software vendors build, as well as, and you'll hear a little bit about our work in the pediatric cloud, research applications that could be enabled to, as an example, be able to diagnose particular types of cancer or whatever. So research applications and production applications will need to be supported to be able to take full advantage of connecting to these machines out there with the edge. And I'll end with, I think in the future state, some of you are old enough to remember a word called client server computing, but I think the future state's going to look like edge and center cloud computing. So we will have computers, edge computers that are located very close to the machines. And as the machines get smarter and smarter, they are the machines. And they will be connected back to the center cloud applications. We talked about cloud computing in a previous section, whether that's AWS, Azure, Google, Baidu, et cetera. As I shared with you in the Netflix story, obviously they're running at AWS. So I think that's what the next generation applications will look like, will be edge and center cloud computing applications. So with that, hopefully I gave you a little bit of an introduction to at least how I think about edge computing, and edge computing is particularly applied to connecting to things and not people. And hopefully, I covered a couple of five major areas that you can think about in terms of what the edge should look like, the networking, the compute, the management, and the fundamental software infrastructure for doing this. So thank you.